Welcome to this video that provides an introduction to the characteristics of human environmental exposure data. This example is formaldehyde concentrations, a gas measured in indoor air of homes, a collection of older homes in gray, with the gray shown in the gray bars, a collection of newer homes shown in the blue bars. And on the right on the y-axis is the frequency with which formaldehyde concentrations fell into these categories of concentrations. What are these concentrations? They're 2-week average concentrations of formaldehyde in homes in Dallas. 100 residents constructed before 2010, that's the older homes. 100 residences constructed since 2010, that's the blue or newer homes. 100 residences constructed before 2000, that's the gray or older homes. So imagine that you're presented with, or someone's presented with these data, and they're asked to use a parametric method to test the hypothesis that formaldehyde concentrations are equal in the new and older homes. I think you could imagine a pretty standard two-sample t-test being used to test this hypothesis, in which case we know we're going to be focused on measures of the central tendency of these distributions, like the mean, and measures of dispersion, like the variance and the standard deviation. So first, let's take a look at characterizing the distribution of these data. Well, I recommend keeping 4 key steps in mind. One is to plot the distribution, which again already done. Here is shown. The histograms are shown here on the right. Other types of plots can be useful too. That blog post that I mentioned a couple slides ago is one place to go, but for ideas. Here are a couple others. Could be a cumulative probability function, box plot, heat maps, etc. You might want to stratify the data by other variables that relate to your study, if it's appropriate, like was done here. Formaldehyde concentration distribution stratified between two age of home categories. So this is on the right. This chart, this histogram on the right, or pair of histograms on the right, is an example of completing step 1, plot the distribution or distributions. Let's go take a look at and what we see when we look at this plot is that both the formaldehyde concentrations for both the older and the newer homes appear to be moderately skewed right, at least. Let's look at step 2, or key step 2. Examine the descriptive statistics. What's useful, there are probably many different metrics that'd be interesting to look at, but one that's useful, particularly useful, is to examine whether the median and the mean are approximately equal. If they're equal, that suggests the data, or approximately equal, that suggests the data are not too strongly right skewed. But we know for why? Well, we know for a normal distribution, which is symmetric, the mean is the same as the median, right? They're equal, and of course the same as the mode. But when the median and the mean are not equal, it starts to maybe tell you some other characteristics of the data. So let's look at the table here on the right. For the newer homes, the median concentration was 20 microgram per cubic meter, and the mean was 34, nearly 1.75 larger than the median. Right? The mean is like 1.75 larger than the median. Similar over here for the older homes, where the mean is about 50% higher than the median. So the means appear to be greater than the median. That means the mean is being dragged to the right by some higher values. Another characteristic to look at is at what percentile of the distribution does the mean fall. I don't have it showing it here on this table, but in these distributions, the mean's falling around the 75th percentile of the data. Well, we know that in a normal distribution, the mean should be near to the 50th percentile of the distribution, again because the normal is symmetric. when we see the mean is falling at a much higher percentile of distribution, indicates the data are right skewed. Another useful metric is to look at the coefficient of variation. So you may recall the coefficient of variation is the ratio of the standard deviation, shown here as SD, to the mean. So you can see the mean, the standard deviation for the newer homes, 42 microgram per cubic meter, is actually greater than the mean of 34. The fact that the standard deviation is greater than the mean again indicates the distribution is right skewed. Why? Well, think about what if the data followed this distribution and it was normal, mean of 34 and standard deviation of 42, we would expect the one standard deviation to the left of the mean to be 34 minus 42 would be negative 8 microgram per cubic meter. Two standard deviations would be another 42 lower than that, or negative 50 microgram per cubic meter. Doesn't make sense, right? Clearly, that idea of stepping standard deviations away to get to different percentiles or lower percentiles of the normal distribution is not making sense here. It's falling apart. Why? Because the distribution's bunched up at the left end and it's longer tailed on the right end. And when you see a coefficient of variation greater than 1, or even approaching 1, that's another indication the distribution's right skewed. So here are the observations or responses to these questions. Step 3, examine a normal probability plot. A normal probability plot for the new homes is shown on the right. So the lower axis is the standard normal deviate, or z-score, that goes with each observation, assuming the data follow a normal distribution. And then the y-axis is each value, right, the value that corresponds to each z-score. If the data are approximately normally distributed, the plot of standard normal deviate expected if the data followed a normal distribution versus each value would be approximately linear. Well, looking at the black circles and line connecting them here, clearly that's a curve. It's not approximately linear. For comparison, the linear relationship between the y-axis and the x-axis variable is shown with this red line. So just looking at this normal probability plot, we would conclude that the formaldehyde levels in the new homes do not appear to strongly follow a normal distribution, or perhaps may not follow a normal distribution at all. Turns out it's easy to make normal probability plots in base R. If R is a tool you're familiar with, here's some code that will do that for you. It's simply right here, QQ norm, and then put the variable that you want the plot of in the parentheses. And if you want the regression line added to the plot, you add QQ line, and you also call out the same variable here.